Have you ever looked up at the night sky, lost in its infinite expanse, and wondered if someone thousands of years ago, under that very same celestial canvas, saw the same stars, felt the same awe, and asked the same fundamental questions about our place in the universe? The answer is yes, undoubtedly. Ancient civilizations across the world, separated by vast distances and diverse cultures, were all deeply connected to the cosmos. They didn't just passively observe the stars as distant points of light. They meticulously studied them, seeking patterns and meaning in their movements. They charted their movements with incredible precision, tracking their paths across the night sky, and wove them into their myths, their religions, and the very fabric of their daily lives, finding stories written in the stars. The sky was their clock, dictating the rhythm of their days. It was their calendar, marking the passage of seasons and the cycles of agriculture, and it was their sacred text, a source of divine knowledge and cosmic understanding. Imagine standing on a vast open plain thousands of years ago, the Milky Way blazing overhead in all its glory, an awe-inspiring river of light with absolutely no city lights to dim the view or distract from its splendor. For our ancestors, the sky wasn't just a backdrop, it was a living entity, a dynamic and influential force. It was a source of profound mystery, sparking curiosity and wonder, but also a source of practical wisdom, guiding their actions and shaping their beliefs. The regular, predictable motions of the sun, moon, and stars provided a reliable framework for organizing life and understanding the world around them, marking days with the rising and setting of the sun, tracking months through the phases of the moon, and anticipating the changing seasons by observing the position of the stars. This celestial rhythm, this cosmic dance, was the very heartbeat of their civilizations, influencing everything from agriculture to architecture. They built massive stone structures like Stonehenge, carefully aligned with the solstices and equinoxes, turning entire landscapes into elaborate astronomical instruments capable of predicting celestial events. They meticulously etched star charts onto clay tablets, preserving their astronomical knowledge for future generations, and painstakingly carved intricate calendars into stone, marking the passage of time with celestial precision. This wasn't just idle stargazing or superstitious sky-watching. It was the dawn of science, the very beginnings of humanity's quest to understand the universe. Humanity's first great intellectual adventure, driven by curiosity and a thirst for knowledge, began under a canopy of stars, long before the invention of telescopes or modern scientific instruments. That ancient quest for knowledge, that deep-seated desire to understand our place in the cosmos, set the stage for everything that was to come, paving the way for modern science and our current understanding of the universe. The pyramids of Giza are more than just ancient tombs. They are monumental achievements of engineering and design. They're enduring monuments to a complex cosmic worldview, reflecting the pharaohs' connection to the heavens and their belief in eternal life. The Great Pyramid's carefully aligned shafts point to specific stars, such as Thuban, which was the North Star millennia ago, and the constellation Orion. These alignments weren't accidental. They were deliberate choices made by the ancient Egyptians to connect with the celestial realm, reflecting the Egyptians' profound belief in a celestial afterlife and the journey of the soul among the stars. Across the world, Stonehenge stands as an ancient observatory, a testament to the astronomical knowledge of prehistoric cultures. Its stones meticulously aligned with the movements of the sun during the solstices and the cyclical phases of the moon. The builders of Stonehenge were not just primitive people, they were sophisticated astronomers and engineers, capable of incredible feats of planning and construction. They dedicated generations to observing and predicting celestial events with remarkable accuracy, passing down their knowledge through oral traditions and practical application. In the Americas, the ancestral Puebloans, also known as the Anasazi, built intricate structures and kivas to precisely mark the cycles of the sun and moon, integrating astronomy into their daily lives and spiritual practices. While Polynesian navigators, masters of the sea, memorized complex star maps and wave patterns to navigate and cross vast, seemingly endless oceans connecting distant islands. For them, the night sky was more than just a beautiful sight. It was a vital map, a trusted guide, and a profound connection to their ancestral home. These ancient sites, scattered across the globe, are enduring testaments to the power of human observation and ingenuity, achieved with no telescopes, no advanced technology, just unwavering patience, meticulous record-keeping, and an insatiable drive to find meaning and order in the seemingly chaotic sky. They perceived the universe not as a random collection of stars, but as a grand, orderly system governed by predictable rules. And they sought to understand its underlying rules and principles, laying the foundation for future scientific inquiry. This fundamental human impulse to observe, to meticulously measure, and to accurately predict future events based on those observations is, at its core, the very essence of science and the foundation of our modern understanding of the cosmos. The celestial canvas, with its myriad of stars and planets, became humanity's first laboratory, sparking curiosity and driving the quest for knowledge. For ancient cultures, the sky was the ultimate authority on time and survival. Agriculture depended on knowing the seasons, guided by the stars and the sun's position. Navigation relied on celestial signposts like Polaris and the Southern Cross, allowing mariners to explore and connect the world. The stars were their compass and their map. Celestial events shaped spiritual life. Eclipses were omens, lunar cycles set festival dates, and the cosmos was a sacred space. This integration of astronomy into daily life demanded accuracy. Mistakes could mean famine, disaster, or divine displeasure. The need for precision drove them to refine their methods and keep meticulous records. The sky was not just a guide, it was a teacher, demanding patience and understanding. Their relentless pursuit of knowledge laid the groundwork for future discoveries. The lessons of the sky shaped civilizations. In ancient Babylonia, astronomy became a science of numbers. Babylonians kept detailed records on clay tablets, tracking the sun, moon, and 5 visible planets. They noticed the complex, cyclical motions of these wandering stars and developed mathematical systems to predict their paths. Dividing the circle into 360 degrees, they created the zodiac, a celestial coordinate system still used today. Their greatest feat was predicting eclipses using the Saros cycle, giving them immense prestige. The Babylonians shifted astronomy from observation to mathematical theory. They showed the universe could be understood by human minds, not just as omens, but as a system governed by rules. Their legacy shaped astronomy for millennia. Deep in Central America, the Maya became masters of cosmic time. Their observatories, like the Caracol, tracked Venus with astonishing accuracy, calculating its cycle to within a fraction of a day. The Maya created interlocking calendars, the sacred Tzolkin, the solar harb, and the long count, tracking time across centuries. These calendars dictated every aspect of life: rituals, kingship, war, and agriculture. Those who could interpret the sky held immense power. The Maya saw no divide between science and belief. Understanding the cosmos was sacred. Their patient observations unlocked celestial cycles with a precision unmatched for centuries. The Mayan legacy is a testament to the power of integrating science and culture. The shift from myth to science was gradual, but ancient civilizations laid the groundwork. Systematic long-term observation, Babylonian tablets, Egyptian alignments, Mayan calendars became the raw material for future revolutions. The Greeks inherited this data and added logic and geometry, seeking natural explanations for celestial phenomena. They built models to predict and explain the motions of the planets, envisioning a cosmos governed by knowable laws. Thinkers like Aristarchus proposed a sun-centered system. Eratosthenes measured Earth's circumference with remarkable accuracy. Though knowledge was lost in Europe, Islamic scholars preserved and advanced it, building observatories and refining instruments. This preservation set the stage for the Renaissance. Ancient observation and Greek reasoning became the soil for modern science. The Renaissance reignited the ancient quest for cosmic order. Copernicus, using centuries of data, proposed a sun-centered solar system, challenging old dogma. The printing press spread his ideas, inspiring a new generation. Tycho Brahe built an observatory and compiled the most accurate astronomical data yet. His assistant, Johannes Kepler, used this data to discover that planets move in ellipses, not circles, revolutionizing astronomy. Kepler's laws combined ancient observation with mathematical modeling. Galileo, with his telescope, saw mountains on the moon, Jupiter's moons, and the Milky Way's stars, direct evidence against the Earth-centered model. Galileo's work completed the transition from ancient wonder to scientific method. Observation, mathematics, and experimentation became the foundation of modern science. The Great Awakening was the culmination of humanity's cosmic journey. The legacy of ancient astronomy lives on in modern science. Every spacecraft launched, every planetary probe follows paths first mapped by ancient skywatchers. The transit method for finding exoplanets echoes Mayan techniques. Careful long-term observation of celestial cycles. Our study of Earth's climate using natural records mirrors ancient efforts to track cycles and predict change. From mountaintop telescopes to satellites, our tools have changed, but the quest remains the same. The drive to observe, measure, and find patterns is our inheritance. Ancient astronomers taught us to look up and ask big questions. Their work is the living root of all modern science. When we look up at the night sky, at the tapestry of stars that stretches out before us, we join an unbroken chain of curiosity, a lineage of stargazers stretching across millennia. Each generation has looked up and wondered, stretching back to the dawn of humanity, to the very first moments when humans looked up and began to ponder their place in the universe. Our understanding has grown, from a handful of wanderers, points of light that moved across the celestial sphere, to billions of galaxies, island universes teeming with stars and planets, stretching to the very edge of the observable universe. But the wonder remains. That sense of awe, that feeling of connection to something vast and ancient persists. The Babylonians gave us mathematics, the tools to quantify the cosmos, the Greeks logic, a framework for understanding the universe through reason, the Maya, a sense of cosmic time, a deep understanding of the cycles of the heavens. Copernicus, Kepler, and Galileo taught us to trust observation over dogma, to look at the universe with our own eyes and draw our own conclusions. Today, tools like the James Webb Space Telescope let us see the universe's earliest moments, peering back in time to the very first galaxies. We still ask, where did we come from? What were the initial conditions that led to our existence? What is our place? Are we central to the universe, or just a tiny speck in a vast cosmic ocean? Are we alone? Is there life elsewhere in the universe waiting to be discovered? Science is a dynamic, ongoing process, a continuous cycle of observation, hypothesis, and testing. A human story of discovery driven by curiosity and the desire to understand our place in the cosmos. The journey isn't over. The quest for knowledge continues. There are still mysteries to solve, enigmas that challenge our understanding of the universe, and worlds to find, new planets and possibilities waiting to be explored. Our modern science is their legacy, built upon the foundations laid by those who came before, and our discoveries will be our gift to the future, inspiring generations to come. We are all astronomers, each of us playing a part in this grand cosmic story, connected by curiosity to the unfolding story of the cosmos. We are all inheritors of this cosmic legacy,